Welcome everybody to our next AiM Sports webinar. The presentation name today is AiM Sports Hardware: A Deeper Technical Discussion. This is we've been chatting with some folks about our the hardware and how it gets built in AiM Italy, and I thought it would be really fun for you guys as users to get an idea of a little bit of a deeper technical discussion about the hardware, how it's built, and directly from the guy that's in charge of that. And so we've got a co-host today. It's his third time co-hosting with us, Fabrizio Rizzi, the hardware team manager from AiM Sports in Italy. Fabrizio is going to come in and chat with us a little bit about some of the deeper things. I gave him 3 or 4 topics, and you certainly can ask some more questions in the question and answer box about how that other products or some technical questions you may have about general technical questions. Don't get exactly what size resistor or something. So a lot of us may not get value from that, but if you have some good questions, put them into the question and answer box. For those of you watching this later on YouTube, the presentation that we're going to be working off of is linked down in the description box below. It's been placed into the chat box here for the folks here live, and so that'll be available for you later at any time to open that up and take a closer look at some of the pictures and some of the stuff that we're going to talk about. So I appreciate that. Okay, let's jump to the next slide. Just a quick introduction of Fabrizio. Again, like I mentioned, he's been here with us a couple times to talk more specifically about the AiM PDM, and while he will chat about that a little bit because it is part of the hardware package, we're here to talk about the bigger scope. He's currently the head of hardware development for AiM Sportline in Italy. He's worked for AiM since 2014. I've met Fabrizio's came to at least a couple of our of the PRI show in Indianapolis, where we've got to meet and have and share some good conversation over good food, right? And enjoy ourselves. So Fabrizio, tell us a little bit more about yourself, and then we'll kind of get into some of the different pieces of hardware at the AiM factory.
Yeah, for sure. Hi Roger. Hi everyone. I'm in AiM, as you said, from 2014. Initially, I was in charge in the firmware development of the Wi-Fi, and then I moved in the hardware department. Before AiM, I worked as a freelancer for more or less 10 years, and the most famous works that I did was in conjunction with Magneti Marelli and Cobo system. I worked on the Ferrari dashboard, Lamborghini HVC system, and the Maserati dashboard for doors. More or less during that years, I work also in with the aircraft in the light wave, for example, the glass cockpit for a Czech Republic company. And I make some works in other field, for example, in the big company for a CAN bus system for the 485 buses communication and something else. Then I moved in AiM, and today I am the head of the hardware department, and I'm in charge to develop and to work in a team of 5 people for develop hardware board in conjunction with the mechanical part, to study also the mechanical part of the system that is very, very important. For example, if we think to the PDM, we have to move little power that move in it. When you move many current, you change current in it. So you have to develop a big work on this field. So today I want to show something strange, because we speak about also the factory. I show our user where we produce the mechanical part, where we produce the board, we mount the board. we work on the glass of our instruments, and finally where we mount all together to have the final devices.
Perfect. Perfect. Let's go ahead and jump to the first screen in our presentation, and maybe you can again a little bit of depth in what we're looking at, and how many people work on this particular part, and just a little background on these pieces of hardware.
Yeah, this is the SMD assembly department. This is the place where the boards are mounted, and all the components are placed on the board. You can see in this picture all the tool chain to realize that we have 2 pick and place machine that is more or less the heart of the department. These machines are very fast and more precise. We can mount a component, for example, that is less than 1 millimeter of size. After the 2 pick and place machine, we have under the guy you see in the picture an inspection place where the operator check that all the boards are completely assembled. And finally, the oven. We have the big oven that made the fusion of the solder paste to have the board completely mounted. All this process is completely automatic, so the operator places the board, naked board, at the start of the line, and take the final board completely mounted at the end. All the system is completely connected to the server, so we can know which component is mounted on which board. We can also take the story of the component and the board itself. The next slides.
That to work. There we go.
This is the factory where we produce the mechanical part. Some years ago, we bought the little machine in the angle that is completely covered by the other system, and then we moved on 2 new systems. That is the middle one and the first one. That is very bigger, and they are faster respect to the older one. Here we work the aluminum parts of every systems, and we can check with the mechanical department the sample, study the modification, going in pre-release, in the pre-series, and if all is okay, we can start the series production. These CNC machines can work for 24 hours a day, 7 days in a week. So we try to maximize the production to have all our customers completely satisfied and happy. Next one show what the operator has to do when the piece of aluminum worked from the CNC machine goes out from them. We have to check that all the parts are okay. We have to have a final check from the user. We can give them a final treatment by hands, because when the pieces move from here, has to go to the chemical treatment, and we have to be very sure that all is okay. For example, here you can see the PDM 32 chassis. The operator is checking and listing them. And under the PDM 32, you can see what we use as a chassis for a TC hub, for a analog channel expansion, and so on. So we decided some years ago to product all the system and all the part here in factory, to be sure to have a good quality, to have the possibility and the flexibility to move and to change something if we can do it better, or if we decide to change a little to have the system more reliable. So now we produce more or less all inside our factory here in Italy.
And there's what is the amount of handwork that is needed once it comes out of those machines? Is it just minutes, just a visual plus a couple of breaking some corners, or is there a little extra work than that?
No, the extra work is more or less to check that all is okay and to give a final scratch on the corner, and more or less nothing more, because the CNC machine is very precise and very sophisticated.
Okay, so not a ton of handwork, but everything gets looked at, everything gets ready to go before it goes off and gets cleaned, and then of course painted, powder coated, whatever. I don't know what the process is, but colorized in whatever way. Okay, perfect. So let's go to the next one. There you go.
This is the glass department. In AiM, we decided to put every process inside. So you can see in the left the plotter. We bought a 2 plotter machine that is used to print the glass. So we can print the MXG glass, the Micron 5, the camera, and every system that has a glass is produced here. You can show in the upper corner the result of the printing process. The operator is checking that all the figures are completely printed and without any artifacts from the machine. After this, the panel goes into the laser plotter. That is the last figure on the picture. Yeah, the operator give another look to the system, place the system in the plotter, and via a laser we can cut every single figure, and that we place at the cluster. In this example, for you, there's a Micron 5 glass that was printed.
Okay, perfect. Here. There's a room full of people and a room full of stuff.
Yeah, finally we have the lab department that is the place where all devices are mounted. So we took from the other department every single part. We test the board, we program the board. We have the process that put the board into the mechanical part. We have another test here to check that all is okay. And if we have the system completely working with the configuration installed, for example, for the Micron 5, all the data and information that has to be programmed into the system. We close with the glass. We test that the glass is correctly glued in the system, and then we have the system ready to be shipped. So we move from the lab department the single part into the final stage. That is the shipment process that realize in the room close this one. As you can see, we are a lot of people, so we add some bench in the labs, and we are going to move also some guys in place near this to have more possibility to produce the system and to increase the number, because up to date the number are growing, so we have to keep on the right road to have our customers satisfied in the time and in the quality. Maybe the quality is the more important thing that we focus on.
Joe Atkinson asks a question there, Fabrizio, and it's one slide back, so I'll jump up to it. But when we're talking about glass here, is this truly a glass, or is that the Lexan plastic covering over the top of the glass display? What exactly is that?
Exactly, is a special polycarbonate with some treatment above him. We have anti-scratch and anti-reflection treatment. So we have more or less a foil that is 1 meter per 45-46 centimeter. This foil of glass that we call glass, but in reality is a polycarbonate treated by other factory. And we work this complete foil to have a single part for the device.
Okay, so it is a scratch-proof covering that's above the actual display itself.
Yeah.
Okay, perfect. Let's jump. See if I can get this to go. There we go. Okay, the next topic I kind of wanted to chat about as well, and I asked Fabrizio to prepare a little bit about, because I get the question a lot, and I'm sure others do as well. But we had a number of years ago, they came out with the MXS and the MXG, and then gosh, a couple of years later, we came out with the MXS MXG 1.2. And since we get that question a little bit, I thought it might be kind of interesting to have him discuss and give an idea of what's the difference between those two, right? In some technical detail, but not too deep, right? And because all we sell now is the 1.2s, but if a person had the other one or had the option of having that one or upgrading to the 1.2, what really is the difference? So give us a little understanding about the architecture of the original 1.0, let's say, if we want to call them that.
Yeah, when I arrived in AiM, the architecture were more or less the block diagram you can see in the presentation. In the MXS and MXG system, we had two microcontrollers because the main microcontroller was not enough to manage all the features. So the architecture was made by the two microcontroller, a master, that's the microcontroller that manage directly the storage, so the MEMC, the data, the Wi-Fi connection, the AiM CAN, what we call CAN Exp, the USB connection for the PC, a little piece of SRAM. At that time, we manage more or less 1 megabyte of static RAM, and LED drivers. First version of LED drivers, because in the new generation we change also that. All what come from the out of the cluster is was connected to the slave microcontroller. This was dedicated for the analog inputs, the ECU CAN connection. It managed the CAN 2, so the second CAN, the key line, the AiM, that is the inertial movement unit, the connection with the older ECU in RS232. It managed the RPM, the speed inputs, and also the labs. This architecture has a big problem. That was the connection between the two microcontrollers. So we had some problem in manage the data. We have some difficulty to give higher frequency. I have some new feature and so on. Also, the ZDC, that is the graphic display controller, is the part of the microcontroller that manages the TFT, was an older version of the microcontroller system for the TFT. It manages some effect, but for example, it doesn't have the input for a camera. It can't manage circular screen or some effect that we can use now with the new version. So more or less, this is the point that I started to develop the system. Also, the microcontroller was a good microcontrollers, but that, for example, has only 80 megahertz of frequency, and we need more power to introduce my channel, to introduce a new feature that actually we can do with the new architecture. If we move on the next slide, we can see the difference between the older and the newer architecture.
Okay, so let's go to what the 1.2 MXP MXG 1.2. What's the difference here between the two?
The difference is substantially that we have only one microcontroller that is more powerful. We have a 200 megahertz microcontroller with some dedicated peripheral inside. We have also a new GDC, a newer version of GDC. It can manage more widget. It has some effect on the graphics. For example, the transparencies, the fading, the shadow, the management, and this is what we can do with the new configuration. For example, if you see the new TFT that you can use in RS2, in RS3, sorry, you can see that now we can move a circular widget, we can have arrow and more or less more sophisticated graphics respect to the previous one. We have also the possibility to manage a mirror camera input. In this case, we decided to give the possibility to use 2 camera inputs. The memory inside is bigger and faster. We moved from 1 megabyte on the older version to the 32 megabyte to the new one. We improved also the LED drivers, so we can have some effect also on in the LED management. The inertial platform was 6 degrees of freedom, more or less. We have only the gyroscope and the accelerometer. Now we introduce also the magnetometer. We have the possibility to manage the terminating resistor on canvas. And more important, we have the possibility to use internal pull-up and pull-down function. As you can see, the block, the schematic block is easier, and also the possibility inside the microcontroller are very, very bigger. We have a powerful microcontroller, so we can develop also new feature inside it.
Okay, there is a question up there in the question and answer box from Jeff. Does there seem to be a demand for a 1.2 version of the MXL2? It's a piece of hardware that doesn't have there's an MXL2, but we don't have it's been the same ever since it came out.
Yeah, you are right. I don't know if I can speak about it, but I can assure we are working also on MXL2. So in the next month, probably we have also a powerful version of this.
Okay. Okay. And do dashes use a commercial real-time operating system? You talk a bit about the software development environment you work for in the dashes, as far as that part of it, right? Not on the software side, obviously.
We have mainly two stages in the development. We have the hardware development that is made by a dedicated software. We use a Altium Designer, and with this we can work very, very well also with the mechanical guys, because we work in 3D. So we can check the complexity of the board. We can check if the board fits inside the mechanical part. And we have a big vault that is some space to be easy in the server, where all the components are certificated, validated, and stored. So in every new board, we can use only the component that we have delivered and we have certified on other instruments. This is very, very important to avoid some error that in the past could happen. For the other part, that is the firmware, we have a C compiler that can manage all the text that the firmware guys write to control the hardware part. For example, you can image the board as a car and the firmware as the pilot. The firmware is what we use to to move the hardware part of the system. So this is the very, very important and very, very intelligent part of our devices.
Perfect, perfect. I enjoyed that conversation. That was deep and interesting. When we go, some of the same exact process is built into some of these new devices, the PDM process and the EPM, which I don't think we've mentioned here too much. I think it's been mentioned once or twice in the past. So maybe talk a little bit about this screen.
Yeah, this is only to show that the PDM 32 and 8 and also the EPM are derivated from the last architecture. We have all the features I described before for the 1.2 system. And we have also added the remote management of the dash. This is, in my mind, very, very important parts of the system. In this way, what we have done, we have all the critical part, the microcontroller, GDC, and all the information inside the PDM box. And we have in the remote dash more or less only the TFT itself and a little piece of hardware to manage the connection. Connection is very, very important. We moved on a new standard that automotive has adopted some years ago. That is automotive high-speed link. We have more or less 1 gigabyte of data moving from the dash to the PDM. So we need a very, very reliable connection, and we choose the Rosenberger standard. This cable is capable of draw the current we need in the remote dash. Is capable to move all the information of the TFT for realize the image of the TFT from the microcontroller to the dash. And it give also the possibility to put back from the dash the information about the dash itself. For example, the push button, for example, the light sensor. And we have also the possibility to manage the LED, shift light and alarm in the remote dash. This is all managed by the architecture that is the same we have on the 1.2 system. This is very, very important for us because the development was moved from one family, what we can define the dash logger with the TFT to the PDM module. So we have also the firmware that was tested, and the reliability of the firmware during this year is moved completely in the PDM architecture. Naturally, the PDM has to manage also the power output that we haven't in the dash logger system, and it has also a more powerful management of pull up and pull down, because here we have for each input channel a dedicated pull-up resistor for a precision analog system, and 2 kilo ohm to the plus 5 volt reference, and also the possibility to activate the pull down. For what I see, many customers use this to avoid put externally the resistor to manage and to check the lever, the switch, the push button, and something else. This is very, very useful for the loom. We have a clean loom, a correct installation, and all is completely configurable every time by Race Studio 3.
Great information. Eric has a question there that does the speed of the microcontroller determine the max frequency or resolution of a set of sensors, or are we well past that, and even the other ones could handle the maximum amount that we allow? But what do you think about that question?
Microcontroller is 20 megahertz speed rate, respect to the older one that is only 80. This gives us the possibility to introduce in the system more powerful math channel. Some of these enhancements are not visible to the user, but internally are very, very interesting for us, because we can move also the signal at higher frequency. We can apply some sort of digital processing on the signal to have also the completely manage internally to check what's happened, and we have the possibility to know more information about the system, respect the older one. About the external frequencies, we choose to not go higher, because many situations, if the user move the system to higher frequency, where, for example, is not necessary, you can introduce more noise on the signal itself, and the result is that you have a less accurate system that you can use.
I've seen those chips aren't really limiting us to the 1,000 samples, let's say, per second that we allow on some of the channels. But if we allowed it to, say, 2,000 or sometimes I've seen some users that have just turned everything to 1,000 hertz across the board, and then there becomes a point where it gets saturated and the dash can't keep up with the full amount of stuff that's coming at it, including smarty cams and other things that are demanding some of that processing power. So I assume that's what you're talking about. Okay, let's move on to the next. Before we jump into the GPS topic, a couple of questions that are over there. That the Rio 02 enclosure is plastic, which is unusual. This is from Jeff. All previous enclosures have been aluminum. Why did you decide to go with to mold it or 3D print it or however it's built, and not build that out of aluminum? Is it just a processing thing?
Yeah. Typically, all the system was made with the aluminum. Aluminum has a big advantage. If you choose to work with it, you have the possibility to move the heat inside the system out of the system itself. So you can keep the microcontroller cooling by the system itself. Plastic could be a choice, but for what we think, it's not so professional. So in some little device where it's not so important to have the professional system, the bigger resistance of system, or for example, where the weight is very, very important, we move on the plastic case. But typically, we want to stay in the aluminum for these reasons.
But because of weight and heat, if it doesn't need it to transfer it out, it's sometimes the plastic is a better choice, it sounds like, as for individual products. So okay, perfect. Okay, GPS09 was another topic that it's a new version of a product we've had around for a little bit, and I thought it'd be interesting to chat with everybody and let them know the difference between the GPS08 and the 09 and what's out there and what's available for us all now. So if you can describe a little bit about the new 09 sensor.
Yeah, we developed the GPS09 in the past year because we know that it's very, very important for our customer to improve the precision and the number of acquisition point during the use. With the new receiver, we have the possibility to have, for example, four satellites constellation. And so we can improve the precision, because if we use only the GPS information, for example, typically we can see in the sky 7 or 8 satellites. If we add the GLONASS constellation in my office, for example, I can see during the day a variable number of satellites that change from 13, 14 to 21 to 22. When I have the possibility to use all these satellites, I can see the precision, the accuracy that move at very, very important range. For example, I can see here in the office, so inside the factory, accuracy less than 0.5 meter. Also, the number of points per second is very, very important. All the GPS 8 has 10 Hertz navigation rate. With the GPS9, we can have up to 25 Hertz navigation rate. This means that during a curve, during corner, you have more points that can give you the possibility to best analyze the performance of your driving. Also, the sensitivity is increased with the new module. We moved to minus 160 dBm. That is to give you the possibility to understand a very, very, very small signal. And with this small signal, we can have the GPS completely working with the best accuracy it can. Like the GPS 08, we have the same voltage from 80 to 16, and more or less the same current consumption, more or less 50 milliamps.
You mentioned there. You mentioned there in the list that it's GPS GLONASS Beidou, that's a Chinese constellation, yeah, and Galileo. Those last two, are you seeing those information from that coming into the GPS09, or is that built for information that's due to come to us?
Up to now, we have only activated the GPS and GLONASS for the user, but we are testing also the Beidou and the Galileo. Galileo is not completely working here in Europe, is, let me say, in progress. Beidou in the Chinese part of the globe is already working, so we are with our customer testing also the performance of the Beidou in that area. Okay, what we can do, I think in the next month is to check where the system is on the globe and automatically activate which is the constellation of the couple of constellations that best fit for that place. This dynamic management could be maybe also an improvement on the accuracy on the satellites that we can use.
Okay, perfect. So this chip, this GPS09 sensor, it's available to use those, and in the future it'll be intelligently using those when it's the right thing to do. Sounds like.
Yeah, it's only a firmware upgrade that we can release when we are completely sure that the new dynamic management and the new constellation give some. A big accuracy and a big management of the system.
Perfect. We're also coming out with a sensor called the GPS09 Pro. What is that doing that's different than the GPS09?
Yeah, with the new platform, we decided to introduce also in the GPS an AiM. AiM is an enhanced version of the inertial measurement unit that we put in the devices. Why we do this? Because typically when you think to a GPS system, you maybe are also interested in the external condition of the vehicle. So have the information about the acceleration, the gyroscope, and the magnetometer could be useful to introduce a new math channel, and the user with some mathematical algorithm could also take from this data some information related, for example, from the position, the inclination, the movement, roll, pitch, and yaw information about its system. And I think probably in the future, when we give this data to the user and the user try to use it, maybe could be a better way to give additional information on the movement of the vehicle itself.
On the physical dynamics, the physics of where the car is amongst itself, right?
Yes, right.
Drifting, that kind of a thing. It sounds like.
For example, that's an application that acquire this information. Absolutely.
Okay. Okay. Perfect. So, so that there is a GPS09, and there's the Pro that has this additional IMU information, and then there is a third one called the GPS09 Pro Open. And what's the difference between that one and the other two?
Well, the main difference is the Pro version has the possibility to configure also the CAN data, the output CAN data. GPS9 works like the GPS8. So you put in a AiM CAN network, the system recognizes the GPS itself, work with it, and all is ready to be used. But with the Pro version, you can use the GPS in a CAN bus that is not the AiM CAN bus. So you have the possibility to choose the bitrate, because if you have, for example, another system that is already connected at that CAN bus, you have to have the same bitrate to work. We have up to now a default the data available. So we have a table which we specified at which ID we can send information about longitude, latitude, acceleration, gyroscope information, and something else. We are working also on the possibility for the user to set all the parameter, ID, bitrate, and information that the GPS could give to the system. And I think in a couple of months we could be ready to give the user the possibility to completely customize the CAN bus messages from the GPS9. This is the Pro version. Probably we have the free wire connectivity. In the picture show binder connection, but probably we leave to the user the possibility to choose the connection. As the GPS8, we have a different length of cable, and we have also the roof version of the mounting used.
When it comes to that part, cable lengths and how you mount it with a magnet or a stud for a roof mount, the same as GPS08 has been.
Yeah, same. It's the same.
And the other thing that I would add to this, those of you thinking of you know, okay, I see these cool differences between the 09 and the 08, and maybe you have a car that has an 08 on it at this point. If you, the biggest thing that we found is if you go purchase an 09 and you stick that into your MXS 1.2 device, plug it in, make sure that you update the firmware. These need a fresh firmware in order for them to work. It's plug and play, but it has to have the latest firmware on the AiM device. So make sure you keep that in mind. And an 09, if you just think about this, if you break this apart and, you know, can I mount this to an MXL Pista or a device, an older device? Think of it this way: if the 09 it should only be used on devices that are configured in Ray Studio 3. If your device is an older device that's configured in Ray Studio 2, you do not want to plug the 09 is not acceptable to be plugged into those devices. So keep that in mind. And then the only other slight difference that you might see is maybe you're using an MXS 1.2. You've got a GPS09 in there, and we talk about 25 hertz, 25 samples per second that you're going to see, which is powerful and it's great, and it's something that everybody's going to be able to like. When you bring that data into current Ray Studio 2 analysis, the accuracy part is still enhanced, but the data points that you'll actually see inside of Ray Studios 2 will still be just the 10 data points per second. But the accuracy will be better because that's done ahead of getting it into Ray Studio 2. If you bring it into the Ray Studio 3 beta and you turn on the points and you start to look at just the number of points in there, you'll see the 25 samples per second. So just a little bit of detail on the 09 and where it fits into all of you folks that are thinking about grabbing one. So. Okay, anything you want to add to that? Maybe something I messed up or we got it right?
Yeah, you are right.
Okay, perfect. It's it's not something I've done a ton of yet myself. So, okay, so let's jump to the next topic. It's pressure sensors, something that we've been doing at AiM for a little bit, and but we've stepped up that program quite a bit. And I thought it'd be kind of cool for you to chat with the folks and talk about a little bit about how they're made, how they're tested and calibrated, and a little bit of that. And I think it might be an interesting topic for folks.
Yeah, pressure sensors are very, very interesting for me because I put many of my time in development. Start from the 2 years ago. We choose to produce the pressure sensor because we found that the pressure sensor that were available on market are not so reliable, and they haven't the precision that some users ask to us. So we decided to try to develop this sensor with a very, very new, completely different approach to the system. So we check what the market offered to us. We made some investigation on the transducers, on the electronic, and finally we found the right way to develop a very, very important sensor. If we move on the next slide, we can see that we have more or less the pressure sensor for all the installation. This is an extract from the website. You can see we have the bar version, the PSI version, the normal user, and the absolute version of the sensor. We divided them in some categories, and we have also for each one of them the complete datasheet and the use that we can suggest to the user. For example, pressure sensor 0.5 bar for a car and motorcycle, the pressure sensor 0.160 bar also for the cart. We have the M10 screw and also the English metric screw. More or less all user could use our system without any problem. Go deeper in the detail. This is the technical features. Power supply, like the other device we produce from 8 to 16 volt. The accuracy, as I described before, is this sensor are very, very, very precise. We have minus than 0.5% of the fuel scale. We are speaking about the combined non-linearity and hysteresis. So this accuracy is related to both of these characteristics, and this is very, very important point. The characterization is the same for all sensors. So we have 500 millivolt for the low level, that is 0 bar or 0 psi, and 4.5 volt on the full scale. For example, if we take a look to the 0.5 bar, we can measure 500 millivolt at 0 bar and 4.5 volt at 5 bar. Current consumption is very, very low. We are speaking more than 10 milliamps. Temperature working range is from minus 20 degrees Celsius to 135. So I think we can cover all application. All the sensors are sealed IP66. The housing is made by the 316 stainless steel, very, very robust. They are very, very light. The weight is only for 30 grams. Cable length, here we have a standardized measure at 400 millimeter. And as I said, the threads are in the metering and also in English system, M10 and 3824.
Perfect.
If we can take a look inside the sensor, we can find two subsystems. The sensor bridge, that is the sensor element itself, the transducer, and the electronic part. The electronic is the last that we have in the automotive standard. More or less, all the car makers are using the sensor that introduce this new IC. IC is very, very complicated. As you can see, it has the first part that is composed by the analog signal processing. So we have the multiplexer to move from the measure, the temperature compensation, the AD converter, and all that is necessary to transduce the electric value to the digital system. We have the ID conversion, and finally we have digital signal processing. This is made by the DSP, very powerful DSP inside the sensor. And to have the accuracy and the linearity that we declare, we have to develop also the firmware inside this DSP core. The output finally is an analog voltage from 500 millivolt to 4.5 volt, as I said before. If we move to the next slide, we can see how it's done. The space are very, very small, so we have to ultra miniaturize the board. If you can take a look inside, you'll see that all components are very, very close one to other. With the SMD department that I showed before, we can have the possibility now to manage also this very, very small component. And also the transducer is very, very important. We choose an high quality transducer because you can use all sophisticated electronic that you want, but if your transducer from the physical pressure to the electronic part is not a good quality one, your measures couldn't be so accurate.
I mean, a lot of stuff packed into a very small sensor.
Yeah.
I've heard from a lot of people very, very good reports back. A lot of people are using these, have been for a while, and have been very, very happy with them. So it seems like they've been very well received and very well done.
Yeah, the problem in this choice is that every sensor has to be calibrated in factory. This is a very, very important process. To do this, we develop a plate, as you can see on the left, that can carry up to 50 sensors. We have to connect this system to a specific development board, and we have to give an initial configuration to the DSP inside. Then we have to do a full acquisition to give the possibility to DSP to manage all the data. And to do this, we have to put all the system inside a climatic chamber. The process requires 3 temperature points. We decided to fix them to -20, +25, and +120. And for each temperature points, we need 2 pressure points, the lower and the higher. So we test, for example, at -20, at 0 bar, and at 5 bar. We move the temperature in climatic chamber to +25. We redo the measurement, and finally we do the same at 120. So at this point, we have all the information about every single sensor. We have to put all the data in a computerized data calculation algorithm that give us, as a result, the data to be written to the sensor. We write the data to the sensor, and finally we have the sensor that is working. So we can check the system. We choose a medium level of temperature. Typically we check the sensor at 60 degrees, and we move in the range of the pressure. Some samples are also tested at -20 and +120 to assure us that all the process has been done correctly, because this is very, very important to reach the accuracy of 0.5% in the full scale acquisition. I spent many time in this development, because what you see when you bought a sensor is a little piece of stainless steel, but inside the technology, I can assure you, is very, very high. So I'm very, very proud to develop this kind of sensor.
Yeah, absolutely. And I see in the chat that Michael James wrote something while I think he was typing it as I was talking about before, but these are fantastic sensors, small, lightweight, and have proved to be our most reliable pressure sensor that we have ever sold. And just a great testament to all the hard work and all the good parts and all the stuff that you've done and all the testing and setup and calibrations. These have been very, very good for all of our customers. So.
Well, I can say you that in more or less 2 years, we produce more than 5,000 sensors, and no one sensor is coming back from the field to us to check a malfunction or something else. This is very, very good point to start for the new development of our kind of sensor in the futures.
Yeah, zero returning all the way back to the factory. That that's a good number. So very, very good. Very, very good. The any other questions or any other comments that you have as we in the pressure sensor, or any of the rest of the things that we chatted about, because we're kind of coming up towards the end. We're about right on the right time. Anything else you'd have to add there, Fabrizio?
No, I think I've explained more or less all the process. Very, very easy way to not give the user a complicated description, but I can assure it's a very, very big product. I think every user can try one and give us his personal feedback.
Perfect. And you did a great job of filling those out for us too. The only one other thing that I would add before we kind of close out is back in the GPS discussion, the GPS09 is, we were talking about those external sensors, the GPS09, but there is all of our devices that have an internal sensor, the Solo 2s, the Micron 5s, and the MXMs. Those will either already are being built with the GPS09 or right on the edge of being done with that. So if you're new products that have internal stuff is all being built now with the 09 sensor as well.
Yeah.
One thing I did not mention. So, okay, I appreciate it. We've had some pretty good comments. A question just came up that I think might be a great one to kind of end this out. In the future, are there any combo sensors like an oil temp and oil pressure temp sensors merged into a single sensor? Is that something that we are considering?
Yeah, I
hate to put you on the spot, but
more information. But I can assure that we're working also in the new development of sensor in general. Let me say.
So this is something that is being discussed, and so Bruce, you might want to keep your eyes open into the future.
Yeah.
Perfect. I appreciate it. Lots of great information there. If this is something you'd like to hear more about, make sure you let us know. This video, like all the rest, is going to go straight up onto to YouTube. We'll be there within an hour or two, and all the questions that you might have seen some questions that were asked. Those of you watching it later on YouTube, if you didn't get a chance to see the question and answer box, but all of those will be put into a document, and within a day or two will be linked in the description below. So even if you're watching live and you didn't see all the answers to all the questions, come back to our YouTube page, check out this video, and all the questions and answers from this one and every one previous. If you go back to any of them, all the question and answers are answered in a written PDF document. So it'll be placed up there soon. It'll be our 149th video that we've added up there. So tons of information out there for you to take a look at. We are a customer support company. Love to help the folks. Hopefully we'll see you out at the track. Racing season is starting to really ramp up, and we're visiting lots and lots of tracks already. If you don't see us there, or you have a problem during the midweek, just give us a call. There's an 800 number there, or you have all of our email addresses. Make sure you give us a holler if you need any help. The next webinar we're going to have is going to be a week from today, March 16th. We're going to be talking about getting back into the configuration side. We've got some analysis webinars planned coming up soon, and one on Wi-Fi, just to give you an idea kind of what's coming. But next week will be Robinson Shea will be joining us, AiM technician from our Roanoke office. He's going to come in, and we're going to talk about status variables and trigger commands, and maybe a few other things of some of the power of those. We've gotten used to using alarms and LEDs and changing a few things, but one of the areas I always get some questions on, and a lot of our folks do, is what is the real power of the status variables and the trigger commands, those two especially. So we want to talk a little bit about that and show you some of the power and some of them. There's been some new, if you haven't looked at them in a while, there's added features that you can use. We'll talk about some of those and some of the cool things you can do. So that will be coming up to in a week from today. So make sure you check back in with us. And I realize the Zoom, the 1 hour reminder email did not go out for this one. Again, it's not a whole lot I can do about that. I will contact Zoom. It's the second time it's happened to us. If you ever don't get that 1 hour one, go back to any of the old ones and that link will work for you. And we did get quite a few of the folks here live doing that. Some contact information. If you have any other questions about some of the stuff we talked about today, there's Fabrizio's email addresses down there. He's always really good about answering back, and if anything, just maybe we can chat about some things we might want to look at in the future as well. So there's some contact information. If you have any other questions about some stuff we didn't get to, let us know. Appreciate you guys all being here. The next one with Robinson coming up will be a cool one. Again, I've gotten a couple of comments that looking forward to some more analysis type stuff. So those are, as I mentioned, will be coming in the very near future. So appreciate all of you being here. Fabrizio, you have anything else you'd kind of like to help us close this one up with? Anything else you'd like to add?
No, I can only say to you a big thank you for the opportunity to do this presentation and to show to the world how we work here in factory.
I think it's been very enjoyable. From the comments that I've been watching, everybody really enjoyed it, and I know I did as well. So thank you, everybody. Thank you especially Fabrizio for coming in and doing this. I know it's a lot of extra work, and it's late there in Italy, so I appreciate you coming in and doing this. Thanks everybody for coming. Look forward to seeing you again in a week. Talk to you guys all soon.